Alright, so we've graphed piecewise functions before, but now let's do it including quadratic functions. So first of all, recall a piecewise function is just a function that's broken up into different equations, and you use a different equation depending on the x value you plug in. So for instance, if the x value you want to plug in is less than or equal to 0, we'll use this equation. If the x value you want to plug in is between 0 and 5, including the 5, you use this equation, and so on. So let's see if we can graph this function. Alright, so anytime x is less than or equal to 0, we'll be using this equation. So we'll graph this function over here on the left side of the y-axis. So let's do that. So this is a quadratic function. Notice that it's in vertex form. I can just look and know what the vertex is. Okay, so the vertex, the x-coordinate of the vertex would be the opposite of this number. So it would be -3. And the y-coordinate would be -4. So there's my vertex. All I have to do is look at it. Okay, let's do the roots. Let's find the roots. Alright, so to find the roots, I need to set this equal to 0. So 0 equals x plus 3 squared minus 4. Okay, so the easiest way to solve this is by isolating the expression as being squared and take the square root of both sides. So I'm going to add 4. Now I'm going to take the square root of both sides, and that'll give me plus or minus the square root of 4, which is 2. So plus or minus 2 is equal to x plus 3. Okay, subtract 3 from both sides, and I get x equals -3 plus or minus 2. So x would equal -3 plus 2 is -1, or -3 minus 2 is -5. So there's my two roots. I'm going to erase all this just so we get some more room up here. So my roots are -1 and -5. Since I'm allowed to plug in 0 here, it'd be helpful if we knew the initial value. So initial value, plugging in 0. 0 plus 3 is 3. 3 squared is 9. 9 minus 4 would be 5. Alright, so let's see if we can graph this. Notice that the coefficient in front, or the a right here, is a +1, so this should open up. Alright, let's graph the roots. Roots would be at -1, and another root at -5. The vertex would be at -3, exactly where it should be, halfway in between the roots, -4. Okay, so there's my vertex. This opens up, and the initial value is 5. Oh, it should look like this. Notice that I have to stop here at 5. Let me make that look a little better. I have to stop at 5 because I can only use x values that are less than or equal to 0. I can only use these x values out this way, so I have to stop right here. This side would keep on going forever. Alright, good. Alright, let's graph the next equation. Notice it only applies between 0 and 5. So when I get out here to 5, I'm going to have to stop. I can only graph it from 0 to 5. Alright, so let's see what we can figure out about it. Alright, so first of all, let's find the vertex. Remember, the x-coordinate of the vertex is -b over 2a. So that would be -6 over 2 times -1. So -6 over 2 would be 3. So the x-coordinate of the vertex would be 3. How do I find the y-coordinate of the vertex? Well, I plug 3 into the function. So 3 squared is 9. Then that would be negative 9. Plus 6 times 3 is 18. Plus 18. Minus 5. 18 minus 9 is 9. 9 minus 5 is negative. No, I'm sorry. 18 minus 9 is 9. 9 minus 5 is 4. So the vertex is at 3, 4. Make some more room. Vertex is at 3, 4. All right, what about the roots? Okay, so let's find the roots. So I need to set that equal to 0. 0 equals negative x squared plus 6x minus 5. Okay, so this is in the standard form, ax squared plus bx plus c. So I can either factor, use the quadratic formula, or complete the square. I've been nice to you and given you one that factors, so let's do that. First of all, let's make it simpler by making this leading coefficient positive. So I'm going to divide both sides of the equation by negative 1. 0 divided by negative 1 is 0. This side divided by negative 1 would be x squared minus 6x plus 5. Now let's factor x minus 5 and minus 1. So x squared minus x minus 5x is minus 6x and then plus 5. So I have two expressions that I'm multiplying together and the answer is 0. So either one of those expressions can be 0. So either x minus 5 is equal to 0 or x minus 1 equals 0. So either x equals 1 or x equals 5. So my roots are at 1 and 5. Let's make some more room. Roots are 1, 5. Initial value. So I'm going to put a 0 in for x. This term will go away. This term will go away. And I'll just be left with negative 5. All right, so let's see if we can graph this parabola. The leading coefficient is negative, so we know this one opens down. All right, so my roots are at 1 and 5. My vertex is at 3, 4. Here. 3 is exactly in between 1 and 5, just where it should be. It opens down. It should look like this. Pretty nice. My initial value is at negative 5. Here. Oh man, that's an ugly parabola. Try that again. It's not the prettiest parabola in the world, but we get the idea. All right. Notice we can't go past 5 because it has to stop at 5 when x equals 5. Okay, so it stops there. All right. What about here? When I plug 0 into this function, I have to use the top equation. So I should have a solid dot here. I'm not allowed to use 0 on this equation. So I need an open circle right here. That means that point is not included. All right. Okay, next part, between 5 and 7, I'm going to use this equation. Now this is a linear equation, so this should make a straight line. Y equals mx plus b, so the slope is negative 2, the y-intercept is 12. All right, so let's plug in a 5. If I put a 5 in here, negative 2 times 5 is negative 10. Negative 10 plus 12 is 2. But notice I'm going to use an open circle because I'm not allowed to put the 5 in to this equation. The 5 belongs to this. So I have to use an open circle there. Let's put in the 7. Again, I have to use an open circle. But when I put the 7 in, negative 2 times 7 is negative 14, plus 12 is negative 2. So that would be here with an open circle. And just for fun, let's put in the 6. If I put in a 6, negative 2 times 6 is negative 12. Negative 12 plus 12 is 0. So I would get a point here. And this is a linear equation, so it should make a straight line that looks like that. All right, and then the final piece, anytime x is greater than or equal to 7, my output is always going to be 3. So this is a constant function. My output is always 3. Here's 3. I plug in a 7, I get a 3. Anything I plug in bigger than 7, I always get 3. So I'm going to need a straight horizontal line that looks like that.